Okay, this is the P2 paper from June 2024. It's question number 4, and this is an algebraic methods question. In particular, we're going to be looking at the remainder theorem, the factor theorem, and I think we're going to be doing some algebraic long division as well. Okay, let's have a look at part A. It says fx is given by this function up here. And then it says to me, state the remainder when fx is divided by x minus 2. Well, because we can see x minus 2 is in that part there, this is very, very straightforward. So part A, the remainder, if we divided by x minus 2, would just be equal to 21, that part there. So not difficult at all for that first part. Second part says, given that 2x minus 1 is a factor of fx, show that k is equal to 11. So part B, let's write out fx. I haven't written it down yet. So fx is given by x minus 2 multiplied by this 2x squared plus 5x plus k, and then plus 21 here. So if we're saying 2x minus 1 is a factor, then we're saying that f of a half is equal to 0. Why? Because we say if it's a factor, then 2x minus 1 equals 0, 2x equals 1, x equals a half. That's where I'm getting my half from to put into my function. I'm going to get rid of that though. So what does f of a half work out to be? Well, f of a half, oops, sorry, let's sort out the handwriting for that. F of a half is going to be a half minus 2 multiplied by 2 lots of a half squared, 5 lots of a half, plus k, plus 21. So you've now just got to sub all those values in. Well, that's minus 3 over 2 there, and we're going to get a half. We're going to get 5 over 2 plus k plus 21, so that's equal to 0, which means that's equal to 0. So that's minus 3 over 2 times 3 plus k plus 21 equals 0. I'm doing quite a few steps for this simply because, I'll keep going while I'm talking, we are trying to show it's equal to something. So if we were just working out k now, I might do far fewer steps than this, but because we're actually trying to prove it, just take perhaps a couple of extra steps there. So take the 3 over 2 over. Now multiply by the 2, divide by the 3, we get 14 is equal to 3 plus k. So yeah, we get what we were looking for, which is that k is equal to 11. So we've done A and we've done B. So I know what k is now, and it then says, right, fully factorize fx. So I'm going to put k as 11 in here. I'm going to need to multiply this out completely, and then I'll be able to factorize it by doing some algebraic long division. So that's part C, isn't it? So part C, we'll do it down here. We know that fx is equal to x minus 2 multiplied by 2x squared plus 5x plus 11 now, because we know what k is, plus 21. So let's expand that, simplify, let's get what this is as a cubic. So it's going to be x multiplied by that bracket, which gives me 2x cubed, 5x squared, 11x. Then it's going to be minus 2 multiplied by the bracket, so minus 4x squared, minus 10x, minus 22, plus the 21. So finally, fx will be, in its tidiest form, in its simplified form, 2x cubed plus x squared plus x minus 1. So now remember, we know that 2x minus 1 is a factor. So what I'm now going to do is do an algebraic long division using 2x minus 1 as a factor. So I'm going to do the division 2x minus 1 into this thing, and let's see what we get from that. Quick reminder, when we're doing algebraic long division, we're going to say how many times does 2x go into 2x cubed? It goes in x squared times. If it goes in x squared times, I write x squared there, and then I multiply x squared by all of this. and I write the answer here, 2x cubed minus x squared, and once I've done that, I then subtract this, and when I do that, they're always going to cancel, but subtracting this, I'm going to get minus that, minus and a minus makes a plus, so I'll end up with 2x squared here, and then whatever I've got left there, I bring down. So in this case, plus x minus 1. I'm going to do the rest of it a bit quicker now, but I'm going to do exactly the same process. How many times does 2x go into 2x squared? It goes in x times x multiplied by 2x minus 1 is going to give me 2x squared minus x. Subtract that away is going to leave me 2x here, bring the minus 1 down, and then good, I can already see that this has worked. How many times does 2x go into 2x? It goes in once, and when I multiply that and subtract it, I end up with 0 as my remainder, which I wanted because it told me that it was a factor. So I can now say that fx is actually given by 2x minus 1 multiplied by that quotient up there, multiplied by x squared plus x plus 1. Okay, this multiplied by that is now my function. And what they're asking me to do is to solve fx equals 0. So if fx is equal to 0, so that was that part done. So I'm jumping down to part 2. So that's part 1 done. Part 2 says, can we find the number of real solutions of fx equals 0? So yeah, we absolutely can. I don't know why I've called that C. I think it should be called part 1, sorry. Let's call part 1 there. And this is part 2. So it said, so yeah, C part 1, C part 2. Find the total number of real solutions for the equation. Okay, so I've got 2x minus 1, x squared plus x plus 1 equals 0. So I'll have one solution there, and I'll either have 2 real solutions there, or I might have no real solutions there, depending on this quadratic. So that's what I'm going to look at. I'm going to say, for x squared plus x plus 1, how many solutions are there? So for x squared plus x plus 1 equals 0. If I look at the determinant, if I look at the discriminant, sorry, b squared minus 4ac, let's do that. B squared minus 4ac, and that'll work out to be 1 squared minus 4 lots of 1, which is 1 minus 4, which is minus 3. I can see that b squared minus 4ac is less than 0, therefore no real solutions. So in terms of the number of solutions to this equation, only one real solution. I can even tell you what it is. It's x equals a half. So only one real solution then is the answer for C part 2. So that's all of the question done there. Hopefully all of that makes sense to you all.